Closure and associativity.
Yes, repeat it.
Closure and associativity.
Yes, closure and associativity. Okay, so that is with respect to a semi group. Again, based on that, we have seen some more examples. Now, today we are going to see the next kind of algebraic system, and that system is a monoid. So, what is this monoid? So, first of all, we will see what is the definition for monoid. Okay, so this M star is a monoid, and this monoid
So the
should. Hello?
screen is not visible.
Now check it. Is it visible now?
Yes, ma'am.
Okay. So, monoid, this is an algebraic system that should satisfy three properties. First one is a closure property, second one is a associativity, and third one, it should have an identity element. Okay. So, first one is a closure property. So, first two properties are same as that of the for semi group. Now first one is closure. So what is this closure property? We have already seen for any two elements x comma y belongs to M. Here M is for monoid, x star y belongs to M. Means what? After performing this star operation on these two elements, whatever result we will get, that should belongs to monoid M. So this is the closure property. Now second one is for associativity. For this purpose we have taken three elements as x, y, z. So for all x, y, z belongs to M, this should satisfy associativity property. Like x star y star z, this is equals to x star in bracket y star z. This is second property. Now the next, that is last property, that is for an identity element. So we have seen what is a identity element, how we can recognize it. So here we have considered one element x. So for all element x belongs to M, there should exist an identity element E such that x into E is equals to x. Okay, so if you consider this operation star as a addition operation, then this identity element will be 0. Like okay, now consider if that operation is a multiplication operation, then 1 is an identity element for this multiplication operation. So we can consider value for x as 1. So 1 multiplied by 1, it will give you answer as 1 only. So this is the concept of an identity element. So in order to be a monoid, your algebraic system must satisfy three properties. First one is a closure, second one associativity, and third one it should have an identity element. So this is the definition for monoid. Have we understood?
Repeat.
Okay. So last lecture we have seen what is the definition for semi group. So for this semi group it must satisfy two properties. closure property and associativity property. In addition to this semi-group, monoid must satisfy one more property, and that property is for an identity element. So any algebraic system is called as monoid if it is satisfying closure property, associativity property, and if it has an identity element. Then only that algebraic system is called as monoid. So meaning of these two properties, first two properties you know, because these are same as that of the semi-group. Only one more property is there, and that is for an identity element. So what is meaning of this identity element? Identity element म्हणजे काय असतं? सपोज जर आपण ॲडिशन ऑपरेशन कन्सिडर केलं तर त्याचं कसं होणार? इफ युअर इलेमेंट इज 3, ओके, देन व्हॉट इज दी identity element for addition? 0. So 3 plus 0 that is equals to 3. म्हणजे काय? त्या आयडेंटिटी इलेमेंटचा तुमच्या इलेमेंटवर काहीही इफेक्ट होत नाही. That will give original element as a result. That's why 3 plus 0, here our element is 3. So if you add an identity element for addition, that is 0, it will give original element only, that is 3 only. Now consider multiplication operation. So an identity element for multiplication operation is 1. So 3 into 1 that is equals to 3. So again this 1 has nothing, 1 has not affected to the our original element 3. So this is a concept of an identity element. Are you getting now?
Yes.
Okay. Just a minute. Some examples are there based on semi-group and monoid. We will solve it, then we will see next points. So here are the some examples based on semi-group and monoid. Okay. Question number 1. Check whether following algebraic system is semi-group or not. So here set is given, that is W plus. So here W is a set that is containing elements 0, 1, 2 and so on. So we can call this one as set of natural numbers, and plus this is a addition operation on this set W. Now we have to check whether this W plus is a semi-group or not. Okay. So first of all we have to decide what are the properties that should satisfied by this algebraic system. So in order to be a semi-group, it should satisfy closure and associativity property. Now let us check whether this one is satisfying closure property. So for this closure property we can consider any two elements. So now from this set we have to choose any two elements. Now this set is bigger because this is set of natural numbers. We can consider any two elements. Now suppose here I have chosen 1 and 2 because these two elements belongs to W. Now apply said operation. So here that operation is addition operation. So apply addition operation on these two elements, that is 1 plus 2, that is equals to 3. Now check whether 3 belongs to set of natural numbers. Yes, 3 belongs to W. That's why we can say that this given set satisfies closure property. Okay. Now Next, we have to check for associativity, whether this one is satisfying associative property. So for this purpose, I have to choose any three numbers from this W. So here I have chosen 1, 2, 3 because all these three elements belongs to set of natural numbers. Now apply property of associativity on these three numbers. So first bracket is containing 1 plus 2 plus 3. So again 3 plus 3 it is equals to 6. Now RHS 1 plus in bracket 2 plus 3. So again 2 plus 3 that is equals to 5. 1 plus 5 6 means what? Both the sides are same. So we can say that this satisfies closure as well as associativity property. That's why given algebraic system is a semi-group. Have you understood this example?
Yes, ma'am.
Okay. Now here second set is given, second example is given. Let X be any set that is consist of P of X and union operation. So here P of X is a power set of X. Okay. And it is closed under operation union. Means what? We have to perform union operation on power set of X. And then we have to finalize whether this one is a semi-group or not. So here I have taken set X as 1, 2, 3. Means what? Here set X is containing 3 elements. So power set of X will contain how many elements? Total 8 elements as 2 raised to 3. So again we have to define power set for this X, and that is defined as P of X. So first element of power set is 5, second one set 1, set 2, set 3, set 1, 2, set 2, 3, set 1, 3 and set 1, 2, 3. So there are total 8 elements in power set of X. We have already seen this concept of power set in set theory. Now we have to check whether this power set is satisfying closure property and associativity property. So first of all we are going to check for closure property. So for that purpose choose any two elements from this power set of X. So here I have taken two elements as set 2 and set 3. Again these two elements belongs to power set of X. Now whatever operation is given, so here they have mentioned we have to perform union operation on this power set. That's why now I have to apply this union operation on set 2 and set 3. So it will give you answer as set 2, 3. Now check whether this set is present in power set of X. Yes, there is element set 2, 3. Okay. Means what? This given set is satisfying closure property. Okay. Now we have to check for second property, that is for associativity. Now for this property I have to choose 3 elements from power set of X, and here I have taken set 1, set 2 and set 3. 3 elements I have taken. So now apply associativity property. So set 1 union in bracket set 2 union set 3, that is equals to set 1 union set 2 union set 3. So again if you solve this both the brackets, then you will get answer as set 1 union set 2 union set 3. Again RHS is same. So here we can say that LHS is equals to RHS. So this algebraic system satisfies associativity property also. That's why we can say this given example or given algebraic system is a semi-group because it is satisfying closure as well as associativity property. Have you understood how to recognize semigroup?
Yes,
Okay.
ma'am.
Now we have to solve some examples based on monoid. So we have already seen what are the properties required for monoids. That is closure, associativity and identity. So here example is given as check whether n plus is a monoid where n is equals to set. Okay. So here for this given example we have to check whether this n plus is a monod or not. So take 5 minutes and check for all these three properties closure, associativity and identity and tell me your answer within 5 minutes. So first of all tell me, are you able to solve this example? We have solved many examples on semi-group. In this same manner you have to check for monoid. So take 5 minutes and tell me your answer. So let us solve that example. So first of all, we are going to check for closure property. So first of all, I have to choose any two elements from this set N. So here I have taken elements 4 and 5. Now apply whatever operation is given, that is plus operation on these two elements, as 4 plus 5, that is equals to 9. Now check whether 9 belongs to set of natural numbers. Yes, that is correct. 9 belongs to N. So we can say that this satisfies a closure property. Now check for this second property, that is associativity. So for that purpose I have to choose any three numbers from this set N. So here 2, 3, 4, that those numbers I have taken, those belongs to N. So apply associativity property here. So first bracket 2 plus 3 plus 4. So again 5 plus 4, that is equals to 9. And RHS 2 plus in bracket 3 plus 4. So again 2 plus 7, that is equals to 9. So we can say that this satisfies associativity property. Now just last property is remaining, and that is for an identity element. So here this operation is a plus operation. So we can choose 0 because 0 is an identity element for this plus operation and 0 belongs to N. So whatever identity element is required for monad, that is present in this given set. That's why we can say that this satisfies an identity property. So this given algebraic system is satisfying closure, associativity and identity property. That's why this is a monad. Getting it? समझने का example?
Yes,
Yes,
ma'am.
ma'am.
Okay. Yeah. Now, second example is given. Check whether Z multiplication is a monoid where Z is equals to 1, 2, 3, 4, 5 and so on, and this is a multiplication operation. So can you try for this example? Again you have to check for three properties: closure, associativity and identity. At least first of all check for two properties, closure and associativity. Because this kind of examples they have asked in final exam for 4 marks based on semi-group or monad. Check whether given algebraic system is semi-group or it is monoid.
It is semi-group, ma'am.
Semi-group. Okay. Now, yes, this is semi-group, but they have asked for monoid. Now, what is remaining property? In order to be a monad, we have to check for an
Identity
identity
property.
element. Yes, correct. So for this multiplication operation, 1 is an identity element. So first closure, for this property again I have taken 1 and 2. So after applying multiplication operation on these two elements, 1 into 2, that is 2, and 2 belongs to this given set. That's why this satisfies closure property. Now second one is associativity. Again for this I have to choose three elements. So here I have taken 1, 2, 3. So again 1 into 2 into 3. So 2 into 3, 6. And RHS 1 into in bracket 2 into 3. So again it will give us 6. So we can say that this satisfies associativity property. Now just one property is remaining, and that is for an identity element. So for multiplication operation, identity element is 1. Now check whether 1 is present in this given set. Yes, 1 is there. That's why we can say that this satisfies an identity property also. So this given algebraic system satisfies closure, associativity and identity property. That's why this is a monoid. So have you got idea about semigroup and monoid?
Yes, ma'am.
Yes, ma'am.
Okay. Now we will see the next point from this chapter. So that point is homomorphism of semigroup and monoid. Okay. So in the last lecture we have seen what is the definition for homomorphism. So same definition we have to apply here. Just here we have to apply that on semigroup and monoid. So here two different semigroups are given. Let S star and T delta be any two semigroups. A mapping G is from S to T such that for any two elements A comma B belongs to S, G of A star B is equals to G of A delta G of B. This is called as semigroup homomorphism. Means what? Here we have applied that homomorphism on two different semigroups. First semigroup is S star, second one is T delta. And we have taken mapping G from S to T. So for that purpose, we have taken two elements A and B. Those belongs to set S. Now, if you want to apply the function G on these two elements, we can apply as G of A star B. Now, if you want to apply this function G separately on A and B, then you have to take operation from second semigroup. That's why G of A delta G of B. So this is the definition for semigroup homomorphism. Likewise, we have to define homomorphism on monoids. So again, here we have taken two different monoids. Let M star EM. So here EM is an identity element for this monoid M and T delta ET. So ET is an identity element for monoid T. Be any two monoids, the mapping G from M to T such that for any two elements A comma B belongs to M, G of A star B is equals to G of A delta G of B. Up till now, this definition is same as that of the semigroup. Now we have to consider this an identity element. So G of EM means what? If you apply that function G on identity element of M, you will get identity element of T. Then only we can say that these two are in homomorphism with each other. Have we understood these definitions? Okay. Now here they have given one example. So first of all, look at this table and tell me which is an identity element for this composition. Identity element कोणता येईल? Yes. What is the concept of an identity element? जर एखाद्या इलेमेंटवर तुम्ही आयडेंटिटी इलेमेंट अप्लाय केला तर त्याचा आन्सर तुम्हाला ओरिजिनल इलेमेंट मिळायला पाहिजे. सो फ्रॉम दिस यू कॅन चूज E as an identity element. Why? Because E star E. Here this operation is star. That's why E star E, it is E. Again E star 0, it gives us 0, and E star 1, it gives us 1. So here they have mentioned that this set S comma star, this is a semi group, and this set S is consist of three elements as E01. And now we have to check whether this semi group can be a monoid. Yes, this is a monoid because an identity element E is there. That's why this is a monoid. आपण सेमी ग्रुपसाठी काय म्हटलं, क्लोजर आणि असोसिएटिव्हिटी प्रॉपर्टी असेल तर तो सेमी ग्रुप असतो. मोनॉइडसाठी काय आहे, क्लोजर, असोसिएटिव्हिटी अँड आयडेंटिटी, तिन्ही प्रॉपर्टीज सॅटिस्फाय झाला तर तो मोनॉइड होतो. नाउ फॉर दिस सेमी ग्रुप there is a identity element, that's why we can say that this is a monoid. So we can take note of this as every monoid is a semigroup. What is this statement? Every monoid is a semigroup. Why? Because whatever properties are required for semigroup, all those properties are in monoid. That's why every monoid is a semigroup. Now, here one theorem is given, again that is based on homomorphism. So, three semigroups are taken, S star, T delta and V XOR. Function G is from S to T, H is from T to V. B semigroup homomorphisms, then H composition G is from S to V. Okay, is a semigroup homomorphism from S star to V XOR. म्हणजे काय, आतापर्यंत आपण काय डिफाइन केलं, सेमीग्रुप होमोमॉर्फिझम मध्ये we have taken homomorphism between two semigroups, but here in this theorem we have taken three semigroups and we have to prove homomorphism between all these three semigroups. So here consider any two elements, those belongs to set S. Now here I have taken elements as A and B. We have to take composition as H composition G, that is given. So H composition G, we have to apply this one on these two elements as A star B because given operation is star. Now we have to apply this function G on A star B. Okay, so again whenever we have to apply this function G separately on A and B, we have to take operation from next semigroup, and that semigroup is containing operation delta. As hello,
Yes, ma'am.
just a minute, power is off, I will check what has happened. Hello? Hello? Am I audible?
Ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
So let us continue with this theorem. So now we have to apply this function g separately on a and b. That's why we have to consider operation from next semigroup. So how we can apply it? H of g of a delta g of b. Okay. So again one more function is there, h. Now whenever we have to apply this function h separately on g of a and g of b, we have to consider operation from last semigroup, that is XOR. So h in bracket g of a XOR h g of b. So here we have applied that function h separately on g of a and g of b. So again we can take h of g is equals to h of g into a star b is equals to h of g. Here I have taken h of g again outside the bracket as h of g into a means what? This h of g, this composition is applied on a, XOR h of g applied on b. So in this way we can show homomorphism between two or more semigroups. Have we understood this theorem? Hello?
Ma'am, repeat करा
Okay.
क्या? No, ma'am.
So here in the definition of homomorphism of semigroup, what we have done, whenever we have to apply this function g on a and b, how we have taken it? G of a star b. Now if you want to apply that function g separately on elements a and b, then g of a, again we have to consider operation from second semigroup and that operation is delta, then g of b. Okay, म्हणजे काय जर तुम्हाला कंबाइनली अप्लाय करायचं असेल then you can consider operation from first semigroup, but if you want to apply that operation apply that function separately on elements, then you have to consider that operation from second semigroup. So same concept you have to apply here. Here we have to show homomorphism between three semigroups. So first we have taken the function as h of g and we have to apply this function on elements of a and b. So for these elements a and b, first of all we have to apply operation from first semigroup and that operation is a star operation. So h of g a star b. Okay. Now apply this operation g separately on a and b. So what we have seen, whenever we have to apply that operation separately on elements, we have to consider operation from next semigroup. Now here that operation is delta. That's why we have written h of g of a delta g of b. Now we have to apply this operation h separately on g of a and g of b. That's why again I have to consider operation from next semigroup and that operation is a XOR operation. That's why h of g of a XOR h of g of b. So here we have applied all these three operations on a and b. So h of g of a means what? H composition G and that composition is applied on A. XOR H composition G applied on B. So here we can show homomorphism between three semigroups in this way. Got now? Hello.
Yes, ma'am. Yes, ma'am.
Okay. Now let us see the next example. Here S star is a semi-group in which S is containing three elements as A, B, C, and operation star is given. So here mapping G is given as S to S cube. S to S raised to S means what? Now here S is containing three elements. So 3 raised to 3 means what? There will be total 9 elements in that composition. So for that purpose 9 functions are defined. First function is f of A is equals to A means what? This function is for element A. If you apply that function A, you will get A, answer as A. Now f of A on B is equals to B means what? If you apply that function for A on B, you will get B. So if you consider this table, you will get this operation is star operation, and there are total 3 elements as they have said. This set S is containing 3 elements, that is A, B, C, and there will be total 9 elements because mapping is from S to S raised to S. Here is given that mapping. Mapping G is from set S to S raised to S. Now S is containing 3 elements. So here mapping of 3 elements into 3 raised to 3 means what? Total 9 elements. So mapping of 3 elements into 9 elements, and that mapping is shown with the help of this table. So here 3 elements has ABC, those are mapped into 9 elements by using these 3 rows and 3 columns. Now first function is given as f of A is equals to A. Means what? If you apply that function on A, you will get result as A. Now second one, if you apply that function on B, you will get result as B. So if you apply this A on B, you will get answer as B. Again, if you apply that function for A on C, you will get C. So A, C, you will get answer as C. Now check for next one. If you apply for a function of B on A, you will get B. So B on A, you will get B. Again, if you apply that function for B on B, you will get C. So function for B on B, you will get C. So function for B on C, answer is A. So B star C, answer is A. Now last 3 are for element C. So if you apply that function for C on A, you will get C. So C star A is equals to C. Again, function for C on B is equals to A. So C star B, that is equals to A. And last value, function for C on C, that will be B. So C star C, that is equals to B. So this is the composition table for given operation star. Have we understood this problem? Hello? Hello? समझले का problem? Or shall I explain it once again?
Explain again, ma'am.
So here in this example, they have given one semi group, that is S star, and S is containing 3 elements as A, B, C. Operation star is given, that is defined in this table. Now they have defined one mapping G, and that mapping G such that S to S raised to S म्हणजे काय, आता S मध्ये किती एलिमेंट आहेत, 3. So that mapping will be from 3 to 9. So here we have to map that those 3 elements into 9 elements, and that is given by G of A is equals to F of A, G of B is equals to F of B, and G of C is equals to F of C. Means what? We have defined 3 functions on elements A, B, C. Okay. So here first function is F of A is equals to A. Means what? This function is for element A. If you apply that function on A, you will get result as A. So that is shown here. Function is for A. If you apply that function on A, म्हणजे काय, A star A घेतलं तर तुम्हाला आन्सर काय मिळणार आहे, A. Now second function is defined as function for A. If you apply that function on B, you will get B. Means what? A star B, answer is B. Now third one, A, F of A on C, answer is C. Means what? If you take composition, that is here, that is star operation, A star C, answer is C. Now check here, A star C, answer is C. Now likewise, we have to apply those functions for B and C. Now consider next one, and that is for functions of B. So if you apply that function for B on A, so function for B on A, you will get answer as B. So that is shown here, F of B into A, that is equals to B. Next one, F of B on B, that is equals to C. Means what? This is the function for element B. If you apply that function on B, you will get answer as C. Next one, F of B on C, that is equals to A. So if you apply that function for B on C, you will get result as A. And last one, this is for functions of C. So if you apply function for C on element A, you will get C. That's why C star A, that is equals to C. Next one, C star B. The F of C on B means what? C star B. So C star B, that is equals to A. And last one, F of C on C. So if you apply that function of C on C, you will get answer as B. That's why C star C, that is equals to B. So these functions are given, just we have to form this table. Understood now? Hello?
Yes, ma'am.
Okay.
Yes.
Now, next point is a sub-semi group and submonoid. Okay. So, just a minute. So here definitions for sub-semi groups and submonoids are given. Now we have seen what is the definition for semi-group, what is the definition for monoid. Now we have to check for what is a sub-semi group. Okay, so let S star be a semi-group and T is a subset of S. If T is closed under operation star, then T star is said to be sub-semi group of S star. Okay, so here S star, this is given semi group. we have taken another semigroup T star. Okay, so if T is a subset of S and if T is closed under operation star, then we can say that T star is a subsemigroup of given semigroup. Okay, आता हा डिफरन्स आहे तो सेट अँड सबसेटमध्ये आहे, तो सेम डिफरन्स आहे. व्हॉट इज मिनिंग ऑफ सबसेट? Can anyone explain the concept of set and subset? We have already covered all these points in set theory. Subset म्हणजे काय? Subset means what? That will be part of given set. Now suppose your set is consist of numbers from 1 to 10. Okay, then its subset can be elements from 1 to 5 because all the elements of subsets are present in given set. So that second set is a subset of given set. So likewise same concept we have to apply. If S and T, these are the two semigroups, and if T is a subset of S, म्हणजे काय, T मधले जेवढे एलिमेंट आहेत ते जर सगळे S मध्ये असतील, and second condition, if T is closed under operation star, because here we have specified that operation as star for semigroup. That's why T star is said to be subsemigroup of S star. Now similarly we have to apply same concept for submonoid. Now let M star E be a monoid where E is an identity element that we have already seen in the definition of monoid, and T is a subset of M, and if T is closed under operation star and E belongs to T, then T star E is said to be submonoid of M star E. Okay. सेमीग्रुप साठी आपण बघितलं, सेमीग्रुपला काय लागतं? फर्स्ट वन, that second set must be a subset of given set and that should be closed under specified operation. So here that operation is star. So there are two different conditions for sub semigroup. First one, that should be a subset of given set, and second one, that should be closed under specified operation. Okay, so likewise we can define three conditions for monoid. First condition, that second set must be a subset of given set. So here given set is M and second set is T. So first condition, T should be a subset of M. Second condition, set T should be closed under specified operation. So here that operation is star. So T should be closed under operation star. And third one, an identity element E must belong to T. That is E belongs to T. Then only T star E is called as submonoid of original monoid. So these are the definitions for subsemigroup and submonoid. Have we understood how we have defined it?
Explain once again.
Okay. आता सेट अँड सबसेट मध्ये जो डिफरन्स आहे, सेम डिफरन्स सब सेमीग्रुप अँड सेमीग्रुप किंवा सब मोनॉइड अँड मोनॉइड मध्ये आहे. सो फर्स्ट here we have taken one semigroup S star. Okay, now T is a another set and T is a subset of S. आता आपण काय म्हटलं, T is a subset of S. So means what? All the elements of T will be in S. Okay. Now second one, T is closed under operation star. एक तर काय T हा सबसेट आहे S चा and second condition T is closed under operation star. आता closed under operation star means what? Whatever property that is closure property we have seen same property is here. म्हणजे काय आपण जर कुठले पण दोन एलिमेंट सिलेक्ट केले T सेट T मधून and if you apply that operation star on those two elements, whatever result you will get that will be included in T only. That is called as closed under operation star. So here T is a subset of S and T is closed under operation star. That's why T star is sub-semi group of S star. This is the definition for sub-semi group. ही डेफिनेशन समजली आहे का?
Yes, ma'am.
हॅलो.
Yes, ma'am. Yes.
Now next one is for submonad. आता submonad डिफरन्स काय आहे सेमी ग्रुप आणि मोनोइड मध्ये? ऑल द properties of semi group are in monoid, but in monoid there is one additional property and that is for an identity element. So same is applied here. So if M star E is a monoid and if T is subset of M and if T is closed under operation star, and third case is for an identity element, and if E belongs to T, means what? Whatever identity element we have defined for M, if that identity element belongs to T, म्हणजे काय जर तो element E T मध्ये असेल, then only we can say that T star E is a submonoid of M star E. Getting it?
Yes, ma'am. Yes, ma'am.
समजते का? Because all these definitions they have asked for 2 marks. Each definition they will ask for 2 marks. Define sub-semi group and submonoid. So this question will be for 4 marks. So you have to, at that time you have to give definition with proper explanation why this one is called as sub-semi group of given semi-group or submonoid of given monoid. Likewise. Definition समजली का?
Yes, ma'am.
Okay. Now we will solve some example. Okay. So here definition and examples are given for sub-semi group and submonoid. Okay. So definitions we have seen already. Let us see example. So first example that is based on sub-semi group. Okay. So let Z plus is a semi group and now consider E plus where E is a set of even numbers. Okay. आता E काय आहे? Set of even numbers and we have to check whether E plus is a sub-semi group. Okay. Z is a set of integers and E is a set of even numbers. Now first of all we have to check whether E is a subset of Z is, because from set of integers we have defined set of even numbers, set of odd numbers. Likewise means what? All the elements of set E are in Z. That's why we can say that E is a subset of Z. Again, now check whether E is closed under operation plus. आता हे कसं चेक करणार आहे आपण? Again for that purpose we have to choose any 2 elements. Now consider those 2 elements are 2 and 4. Now apply addition operation on these two elements. So 2 plus 4, that is equals to 6. Now check whether 6 belongs to E. Yes, 6 belongs to E because 6 is a even number. That's why E plus is sub semi group of Z plus. Have you understood this example? Hello?
Yes, ma'am.
Okay. So for this सब सेमी ग्रुप फर्स्ट वन एकतर सबसेट असला पाहिजे तो दिलेल्या सेटचा. सेकंड वन दॅट सेकंड सेट मस्ट बी क्लोज्ड अंडर स्पेसिफाईड ऑपरेशन. Then only we can say that second set is a sub semi group of original set. Now second one is for submonoid. Here O star is a submonoid of Z star. What is example? O star. O is a set of odd numbers. Okay. And Z is again set of integers. Now we have to check whether this one is a submonoid. Submonoid असणार आहे का मग Z star चा? And here they have defined this star operation as a multiplication operation. So first of all we have to check whether O is a subset of Z. Yes, because O is a set of odd integers and Z is set of all integers. Means what? All the elements of O are in Z. That's why we can say that O is a subset of Z. Okay, first point is satisfied. Now check whether O is closed under operation multiplication. So how to check it? So again consider any two elements from set O. So you have to choose any two odd numbers. Now consider these numbers are 1 and 3. So 1 into 3, answer is 3. Again 3 belongs to O. So we can say that second property, that is closure property, is satisfied. Now check for an identity element. So for this multiplication operation, identity element is 1. Now check whether 1 is present in O. Is because again 1 is a odd number. That's why 1 belongs to O. That's why we can say that O star is a submonoid of Z star. Have you understood this example?
Yes, ma'am.
Okay. Now second example is given for again submonoid, that is E plus is a submonoid of Z plus. So now you have to tell me how we can prove whether E plus is a submonoid of Z plus. आता तुम्ही सांगायचं explanation. There are 3 different points in order to be submonoid. First one, that second set must be a subset of given set. Second one is given as there should be a closure property. Means what? Our second set must be closed under specified operation. And third one, there should exist an identity element. Now check for this set E plus, whether E plus is a submonoid of Z plus. You have to explain. Is who will explain? consider first, that is subset condition. Check whether E plus is a subset of Z plus. आहे का subset?
Yes, ma'am.
Yes, because set of even numbers are from integer numbers only. Okay, now second one, check whether E is closed under operation addition.
Yes, ma'am.
Yes, because if you apply addition operation on any two elements of set E, you will get even number only, and that number will be included in set E. That's why that second condition is also true. Now check whether an identity element for addition operation is exist in set E. So first of all, which one is an identity element for addition operation?
0.
0. And
0.
that element is, and that element belongs to even numbers. That's why all these three cases becomes true. That's why E plus is a submonad of Z plus. Understood these concepts?
Yes, ma'am.
Yes, ma'am.
Okay. Now we have to see the next point from this chapter. Only few points are remaining now. So here is the concept of direct product. Okay. So here we have to take direct product between two semigroups. So let S star and T delta be any two semigroups. The direct product of S star and T delta is the algebraic system S direct product T composition, in which operation composition on S direct product T is defined by, that definition is given here. If S1 and S2, if you consider these two elements from set S, then S1 T1, S2 T2, this is equals to S1 star S2, comma T1 delta T2. For any S1 T1 and S2 T2 belongs to S star S direct product T. आता याचं मीनिंग काय डायरेक्ट प्रोडक्ट म्हणजे दिस इज जस्ट लाईक ए मल्टिप्लिकेशन ऑपरेशन. ओके, सो हियर वी हॅव टू टेक दॅट डायरेक्ट प्रोडक्ट बिटवीन टू सेमी ग्रुप्स. Those semi groups are defined as S star and T delta. Okay, now here that direct product is written as S, that a multiplication operation is a for direct product. So S direct product T, and whatever operation we will get after that direct product, that is defined as composition. Okay, so again here S1 T1, these two elements belongs to set S, and T1 T2 belong to set T. Now we have to take direct product. That's why we have taken here S1 T1 S2 T2. म्हणजे काय S1 T1, these are for S star T, that is S direct product T. Again S2 T2, again those will belong to S direct product T. So how we can take direct product? So S1, now this S1 S2, these are the elements from set S, and which operation we have defined on set S, that operation is a star operation. That's why we have to apply star operation on S1 and S2. So S1 star S2. Now T1, T2, these two elements are from set T, and for this set T we have defined delta operation. That's why T1 delta T2. So this is the direct product for any two semi groups. Definition समजली का? डायरेक्ट प्रोडक्ट म्हणजे काय करायचं नाही आहे, फक्त जसं आपण मल्टिप्लिकेशन करतो त्याच टाईपमध्ये आहे. जस्ट यू हॅव टू लुक फॉर वॉट ऑपरेशन वी हॅव डिफाईन्ड ऑन दॅट सेमी ग्रुप. आता S1 स्टार S2 का लिहिलं आपण? बिकॉज these two elements S1 is S2 belongs to set S, आणि त्या सेट S वर आपण कुठलं ऑपरेशन डिफाईन केलं? स्टार ऑपरेशन. दॅट्स वाय S1 स्टार S2. आता T1 T2 साठी आपण डेल्टा ऑपरेशन का घेतला? बिकॉज T1 T2 these two elements belongs to set T, and for this set T we have defined operation delta. So this is direct product if we take order pairs S1 T1 S2 T2. Have we understood? Hello?
Yes, ma'am.
Okay. Now some notes are given. If S direct product T composition is a semi group and star and delta both are associative, therefore direct product of any semi group is a semi group. म्हणजे काय, जर आपण एक सेमी ग्रुप घेतला आणि तो सेमी ग्रुप कोणता आहे? एस डायरेक्ट प्रोडक्ट टी. मीन्स वॉट? हियर वी हॅव टेकन डायरेक्ट प्रोडक्ट बिटवीन एस अँड टी, and if that is semi group, then whatever result you will get after taking direct product, then that will be also a semi group. म्हणजे काय, दोन सेमी ग्रुपचा डायरेक्ट प्रोडक्ट घेतला तर त्याचा जो रिझल्ट मिळतो तो पण सेमी ग्रुपच असणार आहे. सेकंड, if S star and T delta both are commutative, then their product is commutative. Okay. So again, if these two semi groups are commutative, then whatever result we will get after taking direct product, that will be also a commutative. म्हणजे काय, जर तुमचे ओरिजिनल दोन सेट सेमी ग्रुप असतील ते जर असोसिएटिव्ह प्रॉपर्टी सॅटिस्फाय करत असतील आणि डायरेक्ट प्रोडक्ट घेतल्यानंतर जो सेमी ग्रुप मिळेल तो पण मग असोसिएटिव्ह असणार आहे. सेकंड, जर तुमचे दोन्ही सेमी ग्रुप कम्युटेटिव्ह असतील तर डायरेक्ट प्रोडक्ट अप्लाय केल्यानंतर जो रिझल्ट मिळेल किंवा जो सेमी ग्रुप असणार आहे तो पण कम्युटेटिव्ह असणार आहे. अँड लास्ट वन, if S star and T delta are the monoids with ES and ET as an identity element for S and T, then their direct product S direct product T composition is also a monoid with ES and ET as identity element. Okay. So if you consider this is for monoid, so if S star and T delta, if these are two different monoids and ES and ET, these are the identity elements from set S and set T. ES means what? E is for an identity element, and that identity element is defined for set S. That's why ES. Again ET. ET means what? E is an identity element and that is defined for set T. That's why ET. हे जर आयडेंटिटी एलिमेंट असतील तर आफ्टर टेकिंग ए डायरेक्ट प्रोडक्ट बिटवीन S and T, we will get a monad and that monoid will contain both identity elements ES and ET. So this is the concept for direct product. Meaning समजलं का डायरेक्ट प्रोडक्टचं? Hello. If there is no
Ma'am, last
response,
property.
yes, last one.
Sorry?
Okay.
Last property repeat.
Third one
Yes,
for
ma'am. Yes.
monoid. Yes. Okay.
Yes.
So here we have taken two monoids. First monoid is S star, second one is T delta. Okay. Now monoid means what? It must have an identity element. That's why ES and ET. These two are identity elements for set S and set T. Okay. Now if you consider direct product between S and T, that direct product is given as S direct product T composition. So this is the direct product between monoid S and T. Okay. Now for this direct product, whatever identity elements we have defined for set S and set T, that is ES and ET, these two identity elements will be there in direct product. आता मोनॉड आहे म्हटल्यावर त्याचे जे रिस्पेक्टिव्ह आयडेंटिटी एलिमेंट्स असणार आहेत, सो दोज आयडेंटिटी एलिमेंट्स also will be there in direct product. So this is last point for monoid direct product. Direct product म्हणजे आपण काय बघितलं? फर्स्ट whatever operations are there, आता S1 S2 S1 T1 S2 T2, if we consider two order pairs, then we can apply direct product as S1 star S2. So why we have taken here star operation only? Because S1 and S2 belongs to set S, and for this set S we have defined star operation. So we can take direct product between S1 and S2 as S1 star S2. Second one, if you consider T1 T2, so T1 T2 belongs to set T, and for this set we have defined delta operation. So T1 delta T2. So in this way we can take direct product between any two semi groups. Again, for this direct product they have specified some points. So first one, if your semi group, and if that semi group is a associative, then whatever result we will get after taking direct product, that will also be a associative. Second one, if your semi groups are satisfying commutative property, then whatever result we will get after taking direct product, that will also be a commutative. And third one, that is for monoid. If you are going to take direct product between any two monoids, then whatever identity elements we have taken for these two monoids, those identity elements will be there in direct product. So this is the definition for direct product. So last time they have asked this definition for 2 marks. If they have just asked definition, then you can just define it. It is not required to give all these remaining points. If they have explained, if they have asked the question like explain the concept of direct product, at that time you must have to include definition and all these 3 points. So this is for this unit number 6. Do we have any doubt regarding any point? So here in this chapter we have covered what is an algebraic system, what are the properties of algebraic system. After that we have seen two different algebraic systems, that is semigroup and monad. Again for this semigroup and monad we have seen homomorphism, that is homomorphism of semigroup, homomorphism of monad. After that we have seen what is the submonad and subsemigroup, and last point, that is direct product between semigroups and monads. So all these points we have covered in this chapter. So now tell me, do you have any doubt regarding any point? समजलं का चॅप्टर?
Hello, ma'am.
हॅलो, येस.
Identity property सांगता का तुम्हाला?
आयडेंटिटी
Property.
डायरेक्ट प्रोडक्ट मध्ये आयडेंटिटी प्रॉपर्टी फॉर whom? Monad or direct product?
Monad.
Monad. Okay. आपण सेमी साठी कोणते प्रॉपर्टीज डिफाइन केले? क्लोजर अँड असोसिएटिव्ह. सो इफ यू वॉन्ट टू चेक फॉर मोनॉइड, that monad will contain one more property, that is additional property, and that property is for an identity element. So we can define monad as here. So monad can be defined as algebraic system or algebraic structure M star, and that is satisfying three properties. First one closure, second one associativity, and last one that is for an identity element. So what is meaning of this identity element? If you consider any element x that belong to M, x star e that is equals to x. म्हणजे काय, जर तुम्ही x हा element 4 कन्सिडर केला, ओके, and now suppose that operation star, आता star operation it can be anything. Now consider that is operation for addition. Okay, so 4 plus something that is equals to 4. आपल्याला आयडेंटिटी इलेमेंट म्हणजे काय, त्या इलेमेंटचा जो आपण इलेमेंट चूज केलाय त्याच्यावर इफेक्ट होता कामा नाही. सपोज 4 हा इलेमेंट घेतला आणि ॲडिशन ऑपरेशन घेतलं तर तुमचं आन्सर हे 4च यायला पाहिजे. सो 4 प्लस blank space, we have to recognize which one is an identity element for addition operation. 4 plus space that is equals to 4. आता 4 हे आन्सर आपल्याला कधी मिळणार आहे फॉर दिस ॲडिशन ऑपरेशन? 4 plus 0?
0.
Yes, 0 only we can take because 4 plus 0 that is 4. That's why 0 is an identity element for addition operation. So likewise we can define for multiplication. आता 4 multiplied by something that is equals to 4. काय येईल मग? 4 into yes, 4 into 1 that is equals to 4. So here that 0 or 1 has not affected original element 4. That's why we can say that 0 is an identity element for addition operation and 1 is an identity element for multiplication operation. So this is the concept of identity element. Have you understood now?
Yes, ma'am.
Okay. Any another doubt? Okay. So here we have completed unit number 6. Next lecture onwards, we will start with unit number 7. Again, that is based on groups, that is group theory. Again, if you understood semi-group monad, then only you will get concept of group. So first of all, clear all your concepts for this semi-group and monad, because all these properties are there in group. In addition to these properties, some more properties are there in group. That's why you must understood what is semi-group, monad and properties. Thank you. So today we are going to stop here. Give presenting. Roll number 1,
Yes, ma'am.
2,
Present, ma'am.
3,
Yes, ma'am.
4,
Yes, ma'am.
5. Roll number 5, 6,
Present, ma'am.
7, 8,
Present, ma'am.
9,
Present, ma'am.
10,
Present, ma'am.
11,
Ma'am.
12,
Present, ma'am.
13,
Yes, ma'am.
14,
Yes, ma'am.
15,
Present, ma'am.
16,
Present, ma'am.
17,
Present, ma'am.
18,
Present, ma'am.
19,
Present, ma'am.
20, 21,
Yes, ma'am.
22,
Present, ma'am.
23, 24, 25,
Yes, ma'am.
26, 27,
Present, ma'am.
28, 29,
Yes, ma'am.
30, 31,
Yes, ma'am.
32, 33,
Present, ma'am.
34, 35,
Present, ma'am.
36, 37,
Present.
38,
Present, ma'am.
39,
Present, ma'am.
40, 41, 42,
Yes, ma'am.
43,
Present, ma'am.
44,
Yes, ma'am.
45, 46,
Yes, ma'am.
47, 48,
Yes, madam.
49,
Yes, madam.
50,
Present, ma'am.
51,
Present, ma'am.
52, 53, 54,
Yes, ma'am.
55,
Yes, ma'am.
56, 57,
Yes, ma'am.
58,
Present, ma'am.
59, 60,
Yes, ma'am.
61, 62,
Present, ma'am. Ma'am,
63,
present, ma'am.
61.
Present, ma'am.
Okay. 64,
Present, ma'am.
65, 66,
Present, ma'am.
67,
Present, ma'am.
68, 69, 70,
Yes.
check for absent numbers. Roll number 5, 7, 20, 20, 23, 26, 28, 32, 34, 36, 40, 45, 47, 52, 53, 56, 59, 65, 68, 69 and 70.
Hello, ma'am.
Hello?
Ma'am, 59 present, ma'am.
Okay.
Ma'am, 68 present.
68.
Ma'am, 40.
40. Okay.